Hi, myself as Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. In this lecture, we are going to discuss the definitions and terminology on input-output organization and memory organization. So, in digital computer system, memory is a very essential component. So, since it is needed for storing programs and data. So, memory is so basically if you consider a digital computer system, mainly it has three functional parts that are central processing unit, memory subsystem, and input or output subsystem. So, this memory is an essential component in any digital computer because here inside the memory we are storing some programs and the data. So a very small computer with a limited application may be able to fulfill its intended task without the need for additional storage capacity. So most general purpose computers would run more efficiently if they were equipped with additional storage capacity, additional storage beyond the capacity of the main memory. So with a limited application, a small computer with a limited application, it is sufficient to run efficiently. But if you want to run more efficiently, but for more general purpose computers, that means for the large number of applications, it requires more storage capacity so that it can run efficiently. So it is more economical to use low cost storage devices to serve as a backup for storing information that is not currently needed by the CPU. So the low cost storage devices we are using as the backup purposes. That means only the programs and data needed by the CPU are only stored in the main memory, that is nothing but RAM, and the unused programs and data are stored in the auxiliary memory. That means secondary memory. So that secondary memories are designed with low cost storage. So low cost storage devices. So this is a memory hierarchy of the computer system. So this block diagram, it shows how various memory devices are connected with the CPU. So here we can see main memory, cache memory, and auxiliary memory such as magnetic tapes and magnetic disks. So the examples of the auxiliary memories are magnetic tapes and magnetic disks. So and we are connecting these auxiliary memories through the I/O processor, and finally we have a CPU. So the main memory, it is directly connected to the CPU. So that means the memory which can directly accessible by the CPU is called main memory. So in main memory we can store only the programs and the data which are currently needed by the CPU, and all the unnecessary or not used programs and data are stored in auxiliary memory. So whenever that programs are needed, the programs and data are needed, then such programs and data are transferring from auxiliary memory to the main memory. Okay, so always the programs and data will run in the main memory. Suppose after completion of the execution, if the programs are not needed, then they will be returned back to the auxiliary memory, because we are always clearing the main memory, because the main memory is a limited memory. So that's why we are the unused programs and data are storing in the auxiliary memory, and whatever the programs and data needed currently by the CPU only reside in the main memory. And coming to the cache memory, so this cache memory is it will matches the data transfer rates of the main memory and the CPU, because the cache memory is a very fast but small in size. Okay, so the cache memory, the CPU can access the data from the cache memory at a faster rate than the main memory, because when the CPU access any data, first it checks the cache memory. If that is available, then the CPU can access from the cache memory. Otherwise, the CPU will go to the main memory, so it will search in the main memory. So even the data is not available in the main memory, then it will search in the auxiliary memory. So when the data is present in the auxiliary memory, that will be transferred to the main memory, and from the memory it will be accessed by the CPU. So when the CPU, when the data is searching in the main memory, if that searched data is available in main memory, that will be sent to the CPU. So along with the data, one copy of the same data will be transferred to the cache memory. So if the CPU is searching the same data in another time, first the CPU will check in cache memory. So if the data is available in cache memory, then the CPU can access the data directly from the cache memory. Otherwise, it will go to the main memory. So this is how the cache memory works in the computer system. And here we have IO processor. So these auxiliary memories are accessed by the CPU through the IO processor, because the IO processor, it performs various operations related to the input or output devices, whereas the processor, which is available in the central processing unit, it is a general purpose processor. So it performs all the general purpose arithmetic and logical shift operations. And the definition of the main memory. So main memory is the memory unit that communicates directly with the CPU, is called main memory. That is a main memory. Coming to the auxiliary memory. So auxiliary memories are the secondary memories, or we can also call backup storage devices. So devices that provide backup storage are called auxiliary memory. So the most common auxiliary memory devices used in computer systems are the magnetic disks and tapes. So they are used for storing programs, large data files, and other backup information. So these are the auxiliary memory. So auxiliary memory means it can be used for backup purposes, for the future purpose. And the examples of the auxiliary memories are magnetic tapes and magnetic disks. And we have the main memory. So the main memory is the RAM. So RAM is considered as the main memory. So these RAMs are classified into two types. One is SRAM, another one is the DRAM. So SRAM means static RAM, static random access memory, and DRAM means dynamic random access memory. So we will see the comparison between the SRAM and DRAM. So first one is SRAM has lower access time, so it is faster compared to the SRAM. So DRAM. So SRAM, it has lower access time. That's why its speed is more or faster when you compare with the DRAM, because the access time of the SRAM is 10 nanoseconds, whereas the access time for the DRAM is 50 nanoseconds to 150 nanoseconds. So that means here the access time is very high. So if access time is very high, then it would be slower when you compare with the SRAM, because the access time is inversely proportional to the speed. If the access time is high, then speed will be reduced. Second one, SRAM is costlier than DRAM. So SRAM is costlier because SRAM is costlier than DRAM. So because here in the for the manufacturing of the SRAM cell, we require 6 MOS transistors, whereas the DRAM for the construction of the DRAM cell, it takes one transistor plus one capacitor. So that means here for the construction of the SRAM cell, it requires more hardware. So the more hardware is directly proportional to the costly. That means as the hardware complexity increases, the cost also increases. So here in the for the DRAM, the cost is less when you compare with the SRAM, because for the construction of the DRAM cell, it requires one transistor, one MOS transistor, and one capacitor. So here the hardware complexity is very less. So that's why it is less costlier. Third one, SRAM requires a constant power supply, which means this type of memory consumes more power. So as already in previous point we have discussed, in the SRAM more hardware required because more number of MOS transistors are there. So the power consumption, it is directly proportional to the hardware complexity, because as the complexity of the hardware increases, power consumption also increases. But whereas in the DRAM, it is less. And fourth point, due to complex internal circuitry, less storage capacity is available compared to the same physical size of the DRAM memory chip. So due to the internal circuitry, it has less storage capacity. But in the DRAM, it has more storage capacity because the internal circuitry is very small. And fifth one is SRAM has low packaging density. And DRAM has high packaging density, because here in SRAM more number of components are there. So that's why it has a low packing density, whereas the DRAM has high packaging density. So these are the main differences between the SRAM and the DRAM. And coming to the memory hierarchy system, it consists of all storage devices employed in computer system, from slow but high capacity auxiliary memory to relatively faster main memory to an even smaller and faster cache memory accessible to the high speed processing logic. So here different memories are arranged in a pyramid shape. So here from the bottom to top. So in the bottom, so we have a auxiliary memory that are magnetic tapes, magnetic disks, and after that main memory and cache memory, and finally we have a register memory. So all these memories are arranged in increasing order of the access time ratio. Okay, so all these memories. So the auxiliary memories, the examples of auxiliary memories are magnetic tapes and disks. So these auxiliary memories, they have very high storage capacity, but they have very high access time also. That means their speed is very slow. And coming to the main memory, so main memory is its storage capacity is less than the auxiliary memory, but the access time is less than the auxiliary memory. And coming to the cache memory, so cache memory is it is small in storage capacity, but very speed. So access time is very less when you compare with the main memory. And coming to the register memory, so register memory, it is very faster, because the register memory registers are available inside the processor. So for the CPU, it is very easy to access the data from the registers than the cache memory, main memory, and auxiliary memory. So the register memory, it is available in different sizes. It is available in especially in kilobytes, whereas in cache memory it is available in megabytes or gigabytes. So main memory also it is available in few gigabytes, and auxiliary memories are available in terabytes, gigabytes or terabytes. Okay, so all these memory devices they have some properties. So that are storage capacity, cost per bit, access time. So these are the different properties of the materials. So what is storage capacity? Storage capacity is it refers to the total volume of the data that the system's memory can store. That is the storage capacity. So what is storage capacity? Storage capacity is the volume of the data that the system's memory can store. That is called system capacity. So the capacity increases moving from top to bottom in the memory hierarchy. So if you look here, so the storage capacity is increases here from the top to bottom because the register memory is in the kilobytes, cache memory is in the megabytes, and main memory is in gigabytes, and auxiliary memory is in the terabytes. So that's why the storage capacity is in increasing order from the top to bottom. And access time. So access time it refers to the time interval present between request for read or write and the data availability. So access time is the it is a it is a time lapse between the request for read or write and the data available, the requested data available. So between the duration is called access time. So the access time increases as we move from top to bottom in the memory hierarchy. And last, cost per bit. Cost per bit, the cost per bit increases as one moves from bottom to top in the memory hierarchy. So external memory is cheaper than internal memory. So the cost per bit it is increasing as we move from bottom to top because the auxiliary memories are very cheaper because they are available in terabytes for the suppose so 1 TB of hard disk it is available in some 3 to 5k, that means 3 to 5000, whereas in the main memory so it is available in gigabytes. It is a one suppose 4 GB or 8 GB of RAM. It costs around 3500. And if you look to cache memory, so the cache memory is available in megabytes. So that costs some 4000 like that. So that means this cache memory their size is very small, but the cost is high. But in the auxiliary memory, the size is very high, the storage capacity is very high, but the cost is very less. So the cost per bit will increases as we move from bottom to the top. And coming to the auxiliary memory, so the auxiliary memory holds the programs and data for future use. So these auxiliary memories they can be used as for backup purposes because it is a non-volatile memory. So the main reason for using the auxiliary memory is because of its non-volatility in nature. Because non-volatile means even if the power fades, the data stored in the auxiliary memory or secondary memory will be present without losing. So we will not lose any data even the power fails. So that is the main advantage with the auxiliary memories. So it is used to store inactive programs and the archive data. The auxiliary memory is referred to as the low cost, highest space, and slowest approach storage in computer system. So the main properties of the auxiliary memory is low cost, high space, and slowest approach storage. And these auxiliary memories we can also call secondary memory, external memory, backup storage memory, mass storage media. So secondary memory because it is a non-volatile in nature, and external memory because these auxiliary memory are available in outside the CPU. So that's why it is called external memory, and they are using for backup purpose. So that's why these are called backup storage memory and mass storage media because using these auxiliary memories we can store bulk amount of data. And the examples are magnetic tapes and magnetic disks. And the important characteristics of any memory device are access time, access mode, access time, transfer rate, capacity, cost. So first we will see what is access mode. So access mode is the way of searching the storage devices. It is called access method or access mode. That means it is a way of searching the storage device. So the way of searching the storage device is called access mode. So we have several access methods or modes. First one is a sequential access. So in this sequential access, we are searching from the beginning of the memory till the required data found. So this is a memory. Let us assume it is a memory, and the memory starting address of the memory is 0000. Next one is 0010, 0100, and so on. So suppose if we are searching for the 90, so that means in a sequential access, the searching starts from the starting address, all zeros. After that, if the required data is not available in that particular location, it will search in next location. Even that is not available, we are searching in next consecutive memory locations until the searching item is found. So here 90. So we are searching for 90. So we got 90. So our required data is there. Okay. So this is called sequential access. That means for to get the required memory location, we need to go all the sequential memory locations. Example is the magnetic tape. And second one is random access. So the data present at any memory location can be accessed directly. Time taken to access any memory location is same. That means suppose here in the random access, no need to go through the all the sequential memory locations. So directly we can go to the desired memory location from any point, from any place. So suppose I want 90. So that means in random access, directly I can come from starting address 00 to the required address 1000. So that means here in this random access, the time taken to access any memory location is same because directly we can go to the required memory location. So that's why it is called random access. Randomly we can directly go to the desired memory location. Example is a RAM. It is a faster way to retrieve the data. And third one, direct access. So it is a semi-random mode of operation in which the data is stored in blocks or tracks which can be accessed randomly. But here in this, it is unlike the random access, the time taken to access any memory location may not be same. So previously in random access, the accessing the data from any memory location is same, but here it is not same. It is different. So examples are magnetic tapes and magnetic disks and optical disks. And coming to the access time, the access time is the average time required to reach the storage location in memory and obtain its contents is called access time. Okay, so what is access time? Access time is the average time required to reach a storage location in memory and obtain its contains. It is called access time. So this access time, it is a summation of seek time and transfer time. What is seek time? Seek time is the time required to move read or write head into the proper track. And transfer time is once the it is the time required to transfer the data to or from the device. Suppose here, if you see magnetic drum, so here we have a read or write head. This is a read or write head. Read or write head. So this head, it will moves in a vertical on the disk. So that means seek time is the time required to move this read or write head to a particular track. Once the head is placed on the track, then it starts reading the data from that particular track. So that time is called transfer time. So transfer time means it is a time required to transfer data to or from the device. Transfer rate. Transfer rate is the number of characters or words that the device can transfer per second after it has been positioned at the beginning of the record. Then capacity. The amount of data a device can store is called capacity, and then cost. So these are the different characteristics of the memory device. Now coming to the locality of reference. So mainly this locality of reference we are using in the memories. So in practice, most programs exhibit locality which the cache can take advantage. Mainly this locality of reference we are using in the cache memory. So what is locality of reference? Locality of reference is the tendency of the processor to access the same set of memory locations repetitively over a short period of time that will boost or increases the speed of execution. So that is the locality of the reference. So here we have two types of locality of references are there. First one is the temporal locality. Second one is the spatial locality. So temporal locality is the principle of temporal locality says that if a program accesses one memory location or one memory address, there is a good chance that it will access the same address again. Because that means it is especially the temporal locality examples are loops. So in the loops, we are accessing the same set of commands again and again. And coming to the spatial locality, the principle of spatial locality says that if a program accesses one memory address, there is a good chance that it will also access the other nearby addresses. So these are the temporal locality and spatial locality. And coming to the data transmission. So data transmission can be done either in parallel or serial. So data transmission, that means the data can be transmitted from one place to the another place. So that is called data transmission. So that means here we have a transmitter. We have a transmitter and we have a receiver. So this is a sender, this is a receiver. Okay, sender and receiver. So we are transmitting the data from the sender to the receiver. Okay, so that means this data transmission, it can be takes place in two forms that are parallel or serial. So either way we can transmit the data. So in parallel data transmission, the sequence of data can be transmitted parallel at a time. That means all the data from the sender to the receiver will be transmitted at the same time. Whereas in the serial data transmission, the data can be transmitted one bit at a time. That means bit by bit we are transmitting the data from the sender to the receiver. So these are the two types: parallel data transmission, serial data transmission. So data transmissions are two types: serial data transmission, parallel data transmission. And in serial data transmission, again we have two types. First one is a synchronous data transmission, and another one is a asynchronous data transmission. So let's see what is synchronous data transmission and what is asynchronous data transmission. So in general, the serial data can be transferred from source unit to the destination unit in two ways. So these are the two ways to transfer the data from the sender to the receiver, or from source unit to the destination unit. What is synchronous data transfer? So in synchronous data transfer, the source unit and destination unit shares the same clock pulses, means same clock pulse is applied to the registers of the source unit and the destination unit. So in synchronous, we have source unit and destination unit. So this source unit and destination unit, it have some registers. It has some registers. So we are applying same clock to the registers of both the source unit and the destination unit. So that is called synchronous data transfer. Whereas in asynchronous data transfer, we are applying a separate clock to the sender unit, and we are applying another separate clock for the destination unit, source unit and destination unit. So in asynchronous data transmission, we are applying a separate clock for the source unit and the destination unit. So that's why it is called asynchronous data transfer. So in the asynchronous data transfer, this source unit and the destination unit, it doesn't require any synchronization. Okay, so the sender or source unit will transmit the data at one point of time, and the destination unit will receive the data in some other point of time. Okay, but whereas in the synchronous data transfer, both the sender and the receiver, or source unit or destination unit, should have synchronization. So then only the data transfer takes place. And coming to the content addressable memory. So in general, the memory can be accessed by using the memory address. But in content addressable memory, the data is accessed by the data when the data is accessed by data content rather than the data address, then the memory is called associative memory or content addressable memory. Shortly we can call CAM. And the modes of data transfer. So the data transfer between the central system and peripherals, it will be handled in three ways. First one is the programmed I/O, and the second one is the interrupt initiated I/O, and third one is the direct memory access. So using this any one of the method, we can transfer the data between the central system, means CPU, and the peripheral devices. Okay, so in this lecture we have discussed about the definitions and terminology of input-output organization and memory organization. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.